In this next section, we'll focus on search. That's kind of what Elasticsearch is made for. There are so many ways to use Elasticsearch to help your customers find the data that they need quickly. We'll cover different search interfaces you can use, how to sort, paginate, and filter your search results, how to conduct fuzzy queries and partial matches, and even how to implement those search as you type features that you see on many big websites these days. There's a lot of interesting, useful, and valuable information in this section, and as before, it's all hands-on. Let's get started. Let's talk about query line search, which is a handy little shortcut you can use sometimes for experimenting around with Elasticsearch. So in the past, throughout this course, we've been using full-body JSON requests for structuring our search requests, and that's usually the way you want to do it. That's kind of the right way to do it. But if you're just kind of messing around and experimenting, there is a shortcut. It sometimes goes by the name of QueryLite. And it looks like this. You can actually issue a search request without having any request body at all. You can squish it all into the URL, which can make life a little bit easier when you're just messing around with curl and stuff like that. So let's look at this top example. If you issued a GET request through HTTP with just the following URL, it would work. And what this is saying is I want to search the movies index, the movie type, underscore search means I want to do a search request, and the question mark Q equals means I want to issue a search with the following shorthand query, where it has a title that contains the term star. So that little URL, in and of itself, you could just type that into a web browser to the correct port that you're running Elasticsearch on, would bring you back a JSON structure of all the movies that contain the word star in the title. And it's not limited to little simple queries like that either. It's actually very extensible and it can do some very complex things. So look at this second example here. That one's saying Q equals plus year greater than 2010 plus title Trek. And this example would actually search for movies that both have a release year greater than the year 2010 and have Trek in the title. So you can do these sort of Boolean operations with that plus sign, and you can actually even do relational queries where when I mean relational in the sense of greater than, less than, not relational databases, where you can actually compare years to, greater than or less than or equal to some year as well. And there are actually even more complicated things you can do. If you really take the time to understand QueryLite syntax, there's not a whole lot that you can't do with it. But it's not quite as great as it sounds. The problem is when you're sending across URLs, you need to URL encode them very often, and that can make things very confusing very quickly. So you couldn't actually reliably send across that string as is as part of a REST request. You would have to URL encode it in order to securely transmit it over the internet. And that means that any special characters need to be encoded into their hexadecimal equivalents here and coded out. So in reality, you'd end up having to type something like this with all these, %2b instead of an underscore, or %3a instead of a question mark, and %3e instead of a plus sign. In practice, depending on how you're sending these requests across, you might be able to get away with not encoding everything, but for a query like this, there are things you will have to URL encode. And this kind of starts to take away the readability, right? So the practical value of using this as just a quick one-off shortcut kind of gets diminished when you start talking about URL encoding and the need to deal with that. There are also some other reasons why you should not use this little shortcut in production for sure. First of all, these query strings can get pretty cryptic and tough to debug. So while it is powerful and you can cram just about any kind of query that you want onto that URL parameter, it gets pretty wiggly pretty quickly. So you're always better off having a structured JSON request where you can kind of see what's going on in a more structured and manner that makes sense, for lack of a better word. It can also be a security issue. So if you're actually allowing end users to input these URLs somehow, you never want to give end users the ability to just send arbitrary data to your server, right? So, that can be a dangerous thing. An end user could very easily create a search query string that on the URL there that, does some incredibly intensive operation that brings down your cluster. So you definitely want to make sure that you don't open this up to end users. And it's also fragile. Again, these parameters can get very cryptic very quickly, and one wrong character and you're hosed, and it's tough to figure out what's going on. It's related to the first point of it just being cryptic and tough to debug. But if you're just doing quick one-off experimenting or verifying that a search term exists or something like that, for simple, quick one-off things, it can come in handy. So let's take a look at how it actually works. If you want to learn more, just search for URI search. That's what it's formally known these days in Elasticsearch. So if you go to Elasticsearch's website on elastic.co and search for URI search, you'll see the full documentation on how to construct these things. I'm not going to go into it into a ton of depth in this course because, again, you really shouldn't be using it very often. But if you do want to learn more, the information you need is there, and you can see that in addition to the Q parameter, there's many more things you can do as well. You can even specify the analyzer you want, and the query strings that you send across can be very complex, and there's more documentation available there. But let's just do a couple of quick experiments and see how this actually works in practice. All right, let's mess around with query line search, or URI search as it's known these days. Do a quick example here just to show you how it can be handy. So let's do a little search query like we saw in the slides of just searching for things that have the word star in the title. You can do that with a one-liner like this, curl-xget. And I'm going to use a double quote here to enclose everything in because I do have some special characters. And with curl, that can get you pretty far sometimes without having to URL encode things. 27.0.0.1:9200 / movies index / movie type _ search $Q equals title : star, and I'm going to stick and pretty at the end so I get nicely formatted JSON results. And you can see that actually worked. So it gave me back results of all the movies that contain star in the title: Star Trek, Star Wars stuff. Pretty cool. And we did that without any request body at all. So it's a way to quickly do a search query just when you're experimenting, doing a one-off thing without having to mess with JSON requests at all. Let's try and take it one step further, though, and try to run into some of the limitations of this. So let's do that other query where we were searching for movies released newer than 2010 that also contain Trek in the title. That would be something like this: curl-xget quote 127.0.0.1:9200 / movies movie _ search $Q equals, and we're going to say plus to indicate a Boolean AND operation here. Year : greater than, that's the syntax for doing a greater than query, 2010. And then plus for another AND as part of our Boolean operation. Title : Trek, and pretty. And what this should do is give me back all the results that have the word Trek in the title and were released after the year 2010. Okay, and again, I'm using URI search to avoid the need for a JSON body. But wait, that didn't actually work. Why did I get back Interstellar? That doesn't contain the word Trek at all. Star Wars, basically this did not work, and it's not at all obvious why it didn't work. Well, it turns out it's because I didn't URL escape it, so it actually couldn't make sense of anything past that first plus sign. So I ended up doing a query of everything in the entire index because everything after that first plus sign, for you to view what that looked like, just got tossed out because the plus has to be URI encoded, it turns out. So you can see how, this is a great example of the need to URL encode everything that gets sent across. And it's also a great example of how you can get very cryptic results that are difficult to debug. These are both good reasons not to use query line search. Let's actually URL encode this and get around that problem. So I could say curl.xget 127.0.0.1:9200 movies movie _ search $Q equals, and this time I'm going to URL encode that plus sign as %2b, which is just the hexadecimal code for the ASCII value of plus. You can see how this gets to be a pain in the butt real quick. %3a, %3e, 2010, plus %2b title, %3a Trek, and pretty. Whew. And that time I got the results that I want. I mean, so, this is, again, just to drive home the point that it's not as great of a thing as it seems doing URI search. If you compare that search to this search, you can see that it's both much more difficult to construct because you have to look up the URL escape codes for all these different characters. And also, even worse, it's not doing what you thought it would do. Like, it just sort of silently failed on that first query and gave you back results that were unexpected. And again, these are all reasons why you should usually stick with just full JSON query structures within your search requests. And we'll talk about that in more depth in our next lecture.